Hello guys, I'm back. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. And today I will share with you what happens if the pressure condition at the inlet of your compressor changes during your plant design. I am working in a project and we are discussing the modification of the inlet pressure in the barrier limit of the project. What are the impacts that we can have because of that? I will share with you here today at least 3 consequences that leads to the decrease of the inlet pressure of a rotating equipment, especially in a compressor. So when you start your plant design, you must set the basis condition for your process, and you need to know what are the conditions of your raw material at the battery limit of your plant. So you need to know what is the flow, pressure, temperature, composition of your fluid in order that you are able to design correctly the equipment from your process. And once you defined a specific pressure for your compressor and you need to achieve a fixed pressure downstream of your compressor, you have the delta P or the pressure ratio of your equipment. Depending on how big is the pressure ratio, you need to split this pressure ratio in multiples or in many stages for a compressor. And considering that when you did your first preliminary calculations for defining the compressor, and when you are proceeding with the project, there is a change in the inlet pressure conditions of the compressor, what happens? First thing that happens is that if the inlet pressure decreases and you must keep constant the outlet conditions, the discharge conditions, your differential pressure will increase, and that will lead to increase in the heat added to your process, to your stream. Every time you compress a stream, this gas stream, you add heat to this fluid, and because of that, we need to do the cool down at the discharge of the compressor if the process needs to. For instance, if we will feed a second stage of compression, we'll use an intercooler. If we will feed this compressed gas, we'll use an intercooler. In any case, once you increase the differential pressure, you will increase also the delta T between the discharge and the inlet. And because of that, as you are increasing the discharge temperature, your cooling system will require more heat load to be removed from your process. So just because of that, right now you are increasing your power consumption in the utilities, just because once you have a defined pressure condition at the inlet of your compressor and now it is below. Another thing that can happen now, considering that you already installed and your compressor is in operations, when you decrease the inlet pressure in the compressor, you don't have, and considering that the temperature is constant, you don't have the same amount of mass inside the volume, because the volume inside the mass inside, or the mass considered in a volume, in a volume flow, depends on pressure and temperature. So once you decrease the pressure, you have less mass in this fluid, and because of that, you will produce less. I participated in a project where we define the pressure at the inlet condition of the equipment was defined as the same inlet pressure or the same pressure at the battery limit of the project. The problem was that the battery limit of the project, we received natural gas from another supplier, was 100 meters away from the equipment. And when the specification data sheet was sent to the compressor supplier with the pressure condition as the same as the battery limit, of course that between the battery limit and the inlet conditions of the equipment, there are pressure drop because of the pipe length, because of the measurement, because of fittings and etc. And the real pressure at the inlet condition of the compressor was lower than specified, and because of that, the plant was not able to achieve the same production as previously defined. So it's very important that you verify and you consider safety margins to make sure that your equipment will get the required capacity for your process. Another thing that can happens when you increase the differential pressure between the discharge and the inlet is using more power for your compressor if you must keep the same flow. So while you are in the design phase of your project, although you decrease the pressure, the inlet conditions or the pressure condition at the inlet of the compressor, you will still have time to get the same amount of flow in the compressor, because you will update the informations in your specification datasheet and you will send it to the vendor. But once the equipment was purchased, eventually you will not be able to get the same amount of flow. But during design it is possible, but the penalties for that is that now, because you increase the delta P, now it will require more compression, and because of more compression, you will expend more energy to do that. So just because the inlet conditions in your compressor was below what was defined during plant design, you can get more differential temperature in the discharge of the compressor, and that will lead to a higher power consumption, energy consumption. To remove the heat from the process, you will spend more energy. You will increase the delta P in the equipment, and depending on how big is the increase on the delta P, you can change from one model of compressor to another, and that can increase your capex, because different machines can have different prices. And you will also increase the energy for operating the machine, for operating the compressor. And finally, if your compressor is already installed and you have an inlet pressure below what was designed during the plant design, you will have less production, because you have less mass in the same amount of flow per hour. So with this, if you like this video, let me know in the comments and share with other chemical process engineers in order that you can help me to achieve 100,000 chemical process engineers around the world. So guys, this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.